Hello everyone. Welcome to the second section of data wrangling. So in this chapter, in this section, we are going to discuss about how to combine and merge two different data sets. Okay. So when you work on real world programming uh, in data analysis or any machine learning task, you need to work with different because most of the cases, the data that you are going to deal with will be from multiple sources, from multiple files. So you need to work with different data, different sources. You have to combine them together to a single source file or to single data frame. Okay, so for that, you need to know about the options available to combine or merge any data sets or data frame. So in Pandas provides a lot of various methods to perform this task of merging different sources together. We provide join method, concat method, merge method, and combine first. These are the main methods that we can use to merge two different data sets. So the merge method, we're going to practice all of them in this section. So let me just give a review overview on these methods. The merge method will be mostly useful for combining the data based on common column or common indices. Okay, so we use pandas.merge that will connect with rows in two data frame based on a particular given key. Okay, so you have to, it is more like the SQL join operation, but by default, it will perform inner join. Okay, so that we will discuss, we'll practice that. And then join method, this is for combining data on key column. A particular index will be given and the joining will be done based on the particular key. So this will enable you only one data frame, and then you can join the other data frames to that one. Okay, like that. Concatenate method, it will combine data frame across a row or column. You can do both. So what it will do, it will stack it together along a given axis. You can do it if you want to do it in a column, you can do it in column, stack it on column wise, or you can stack it row wise. Okay, so that we can do in concatenation method. And combine first, this method is used to combine two series into one. Okay, so it will be like a union operation in database in SQL, but the thing is like it will just fill. There will be null where some column will be there in one data frame and some column will be missing in other data frame. So what will happen to that null value, missing values? The missing value will be filled with any of those, like it can be filled with the past series or any given default value. With that, it will be filled. The missing values will be filled. Okay, so we are going to see all these four methods in this section, and we are going to discuss about the attributes that is part of each method. Okay, so let's get started. Okay, so first let's create two data frames to perform this task. Okay, so I'm just going to create two data frames. We're going to try all possible joining methods in Pandas. So let's start with merge method. So I have created a data frame. You can refer the PDF. Okay, so I have created two data frames. So let's see what is there. In DF1, you can see it has two columns. And then what is there in DF2? It has these two columns. The key is a common column and data 1 and data 2. Okay, so that is a different column. By default, as I told you, the merge operation that will just combine, but the thing is like it will just do it in any form. How using the how attribute, we can specify whether you want to do inner join. I hope you are familiar with SQL concepts, relational database concepts. You can perform inner join, outer join, or by default, it will be, if you want, you can review the database concepts. Okay, I have shared the link here in the PDF. Okay, so you can just review that. If you want to know more about this, I have shared the link here. You can review that page to know more about that. In relational database, you can perform the joining basically in four methods, right? Left, right, and then inner, outer. Okay, so you can specify what kind of merging you want to perform by using the merge attribute. By default, when you use the merge attribute, it will take the inner join. Okay, df1, I'm just going to join df1 and df2. Okay, so you can see this is the result. It's an example for many to one join method. It has multiple rows. You can see it is labeled as AB, and then you can see here it is ABC, and then here it is ABD. Okay, so the common rows, common key values are AB. So it will just ignore the C and from DF1, and it will ignore D from DF2. Okay, so it will just merge the column which will the common column which is there in both data frames. So common columns which is there in the both data frames are A and B. So it will simply merge A and B, data 1 and data 2. Okay, you can see here B0, B1, and then B6. You can see here. And then all the B values here will be 1 and 0. Here A values will be 2, 4, 5. You can see 2, 4, 5, and that A value here is 0. So like that, it will just merge only the data which is there in both data frames. Here, A and B or the key, these two keys are there in both data frames. So it will simply merge these two. Okay, so now let's create two more data frames. Okay, DF3 and DF4, let's look at that. Okay, so you can see DF3 and DF4, I have created two more. And now I'm going to merge these two, but I'm going to apply these attributes. So I have shared these attributes here in the PDF. So these attributes will be helpful to customize the merging mode. Left attribute will help the data frame to be merged on the left data frame, based on the left data frame. Right will do it in the right side. And how attribute that you can specify whether inner, outer, left, or right. Okay, like that. Left on, it will, what will happen? Columns in left data frame to use as join key. And right on, it is in other words, column in the right data frame will be used with join keys. Okay, DF3 and DF4. Let's merge this. Okay, so I'm going to apply the attribute left on attribute with left merging will be on L key and the right on attribute with R key. So you can see these two L key value, only B will be taken and it will ignore the C because it is not there in this data frame. And then here D will be ignored because it's not there. So only the common key values will be taken. Here it will be merged based on this R key and then this one is F key. Okay, this is left on and right on attribute. So the C and data will be missing. Okay, so if you want to include that missing data as well, then you have to perform outer join. Okay, so the outer join will include the data which is not there. It will include the data which is not there in other data frame as well. For example, here C is not there. C and D both are missing, right? So if you use outer how attribute, and if you specify outer, then you can see C, which is not there in data 2, will be replaced with null. And then here, the D, which is not there in data 1, DF1, that will be replaced with null. Okay. So this is similar. The how attribute, you can just specify whatever we can do in SQL operation, like inner, left, right, out, outer. Okay. So these attribute values, you can specify based on how you want to perform the merging. So next we are going to see about a Cartesian product. You might have learned about this in database. Cartesian product is including everything. Okay, so it is similar like many to many merge. That means all the data will be included in both data frames. That okay, let me explain it with some examples. So I have created another data frame here. Okay, so I have added few more values here, new values here. So the outer one, sorry, when you specify on with key value, that will perform the Cartesian key, Cartesian product. Merge df1, df2 on on key. How and then left. So you can see B5, here it is B1 and 3 values. You can see here Cartesian product will produce, that is 1 and 3. You can see the same thing here will appear 2 times. Okay. So that is the Cartesian product. It is like every time it will be B and A will be joined, and then B and B will be joined, and then B and A will be joined. Like that, each product will be, if there are 4 values, then 16 values will be there in the Cartesian product. So please refer the brush up your skills on relational database to understand this section. Okay, now let's do the same thing with how write and see how that will perform the merging. You can see here it is like the DF2 will be the primary key, and then data it will be merged on the left one, DF1. Okay, so that will happen when you do write. And let's try one more with inner. You can see. So when you do the inner, then obviously it will take away that C and D value. It will just include the common items which is there in both columns. So let me explain it once again. When you specify left as the prime key value, then what will happen? It will ignore the data which is not there in DF1. For example, here C is not there in DF2 and D is not there in DF1. When you perform how with the left operation, left joining operation, then it will ignore the not common item in the right. It will just include C, but it will not include D. In the other case, when you specify how right, you can see that here, C is included here, okay, but D is not there. That is because it is performed on left. If you do it on right, then D will be included, but C will not be included. Let's look at this. So you can see here, D is here, but C is not that because it is merged in the based on DF2, that is on right side, okay? And then if you do the inner one, then by default, it will not include both either C or D. It will just include whatever is common field. A and B only will be included. Okay, that is inner join. In other words, if you do outer join, then what will happen? Both C and D will be included. Okay, so I'm repeating, left will include C but not D, right will include D but not C. Inner will include only the common values, and the outer will include all values. Whether it is common or not, it will include all values, the real Cartesian product. So far we have just merged on only one key value, right? Here, this key value is only one column. But what if we have multiple keys? That is also possible in relational database model. We can have multiple keys in certain cases, right? So when we have multiple keys, how to deal with that? Let's create a data frame. And then merge. On E1, E2. Okay, we have two keys here. How? Okay, so you can see here I value is that, and here left value and right value. Okay, so outer join, when you perform outer join, it will include everything, right? But it should be based on both key values. Maybe I'll show you what is that in each data frame. So that will help you to connect. So you can see this is there in left, and this is there in right. And you merge these two, you can see who, and then three based on this. Okay, 1 1. So 2 4 will be 1 1 1 1, and then 2, and then you can see bar here 1 value and here 1 2 value. So you can see here it just include 1 with not a null. Okay, so when you deal with this merging, we have to look at an issue. We have to consider an overlapping issue. Okay, sometimes the same value will be repeated. So when that happens, how to deal with that? So merge method has an option to deal with this called suffix. Okay, so for specifying a string that can be appended with the overlapping names in left and right. So that can be done. Okay, so let me do merging on these two with outer join. Okay, so let me create another data frame. So let me one more value. So 5 4 5 6 7. So right is already there. Okay. So I'm going to do the merge operation using by adding the suffixes to handle the overlaying problem. On suffixes. Right. So when you do this, you can see with this key 2, we have added left, right. Okay. So based on key 1 value, it will be there because merging is done there. But with the key 2, we have done both left and right, so that overlaying things can be merged separately on key 1 and key 2. Key 2, left and right. Okay, so here, so in the previous case, we have seen how to merge based on one key, and here we have discussed how to merge on two keys. You can either use a list of key value with the on attribute that you can specify how to merge on two keys. There is one more criteria where merging will be done on based on this index value, this 0, 1, 2, 3, 4. Sometimes even key will not be the merging point. Sometimes based on the index, there will be merging. So when index is the merging point, then how can we deal with that? Okay, so maybe we'll create one more data frame to discuss this scenario. Okay, left 1 and right 1. So here, this one is going to be merged based on the key value, this index value. Okay, so how can we do that? PD dot merge left 1, right 1, left on key value, And then here we are going to say the right index is not that, but we are going to say right index is true. So you can see 0, 1, 0, A is there, and then another 2, and then 3, and then after that 1 and 4 will be still B and B values are there. So 1 and 4 values. Okay, so index will be included even though index is not there in the right. So right index will be added. Okay. In the same case, what if we perform how attribute to specify this outer one, then it will include that C as well, right? Let's check that. This right index true option. I'm going to also add one more attribute and specify it is going to be outer. That means even the missing values will be included. What is missing value? Here C is the missing value, right? C will be included here. Thing that we're going to practice is we have discussed about hierarchical indexing in section 1, right? Recall that. So in section 1, we discussed about hierarchical indexing. That means multiple indexing, multiple rows and multiple column labels. So when you perform merging on hierarchical indexing, it will be a little bit more complicated. But let's discuss few things before we move on to the next method, that is join method. Let's discuss few concepts when we perform it using, okay, so hierarchical indexing, the left hedge. So let's say what is that in the left hedge? We have created a simple data, and then next we are going to create a hierarchical indexing, that is right hedge, hierarchical indexing, left hierarchical, right hierarchical indexing. Let's see how this data frame looks like. So this data frame, it has multiple rows. Okay, so it has hierarchical indexing. Now, when we perform merging of these two data frames, that is left hedge and right hedge, how that will work? Okay, for example, let's do the normal join, inner join. CD merge and the data frame left hedge and the data frame right hedge, and then it is going to be on left on. Okay, so key we are going to do on both keys, that is key 1 and key 2. Right index true. You can see Ohio, Nevada, left hedge and right, you can see that here. And when it performs the inner join, obviously it will just take wherever there is a match. Okay, for example, Ohio 2000, Ohio 2001, Ohio 2002 will be there. But since even 2 is not there here, this will not be Ohio, this will not be there. Only 2000, 2001 and 2002 from Ohio. And then there is one more data. Yeah, one more data here, 2000s are there, that will be there. And Nevada, here you can see Nevada, it has 2001 and 2000 is not there. So it will just consider that merging 2000. Okay. So it is similar, but we have two indexes that we have to mind about. Okay, the one with Ohio, and then that will be taken as two keys. Okay, so okay, the outer one, you can see it will just perform the merging on whether it is there in the 2009, Nevada 2000 is not here in left, right and left, and then Nevada 2002 is not in there, right. But you can see when you perform the outer join, it is there in both missing values will be added in the new column, new data frame. I will see one more criteria, how to, if in the previous one, there was index in one left side, but there is no index in right side. But if you perform merging on indexing, and the index is there in both data frame means how can we perform this in merging? We'll see that. Okay, so another hierarchical indexing. Left to looks like this. Okay, and then when you merge these two, right index, left index, sorry, left index, 2. Okay, by default, we're taking the left index true, and then right index also, we are taking 2 because both has indexes. So in the previous case, we have only one index in, that is the left only we had index, but here, since we have 2 indexes, you can see how it got merged. So for missing values, it will just replace it with none, not a number. Okay, for example, here it doesn't have Missouri means wherever A comes, it will replace it with not a null value because the data frame 1 does not have, that is left 2 does not have Missouri and Alabama, so it will just replace it with null. Next, we're going to discuss about join method. Whatever you can perform in merge, you can do that by using the join method as well. For example, whatever you have done here, if you use join, then you don't need to mention about the left index or right index too. It will handle it automatically. For example, pd dot, instead of merge, if you use join, so what we'll do, join will work in other, not like merge. Merge will, you have to give data frame, 2 data frames that will create new data frame after merging. But in join, it will just work on, you will keep one data frame as standard. That means you will keep left, and then you will join the right data frame to that left one. That's how it works. Okay. Okay, so the same thing if you want to do it using join, since join handles with only one data frames at a time, if you want to do this, you have to keep left to 2, and then you're going to join right to that by using join method. How can you do that? Left to join right to. Okay, right to, and how you can specify any method, inner, left, right, or after. Here to check the result, let's do the outer so that we can compare the result. You can see both gives you the same result. Okay, but the only thing, when the difference is merge will work with 2 data frames and then it will merge together as a new data frame, but join will keep one data frame and add a new data frame to that existing one. Okay, so here you can see from left to 2. You can do it in other words as well. Right to join and left to. You can do it in that. Let's try that. Let's do one more. We have the left one right here. We have created what's there in left one. Already we have created a data frame. Left one previously. Okay, right one. Okay, so let's apply the join operation on this. Okay, based on the key value. Left one, join, right one, and then we're going to use the key value, the key on this key. We're going to add join it based on the key value. Okay, you can see based on the key value, which is AB, it will just include everything the same way that we did with the merge. It can do the same thing. Let's work on multiple indexing. So one inconvenient method, the join method will provide you the convenient way of merging 3 data frames, which is very easier. We can do it effectively in using join method. For example, we have already created two data frames here. Let's add a new data frame and name it another. Okay, and now we are going to join this left two and right two, and we are going to add it with another. So how can we do that? Left two dot join right two and then another. You can see here this, maybe I'll show you what is there in another so that you can see. So the another has New York and Oregon, and left two has Ohio and Nevada, and then right two has okay. So what it will do, it will just pick whatever is common. ACE is common. Okay, so it will just pick the values for New York, Oregon, Ohio, Nevada, Missouri, Alabama, only for this rows, because it will focus on only the common rows. It will not mind about column. Whenever the column value is missing, it will just display null value to that. You can see that here. Here, row is there in A is there in all data frames, but column value is missing means those column value it will replace it with not a null value, not a number value. Next, we're going to discuss about concatenation, which is the third method. Before speaking of the pandas concatenation method, we'll briefly discuss about NumPy's concatenation. NumPy also provides concatenation operation. Let's create a NumPy array, and then let's do concatenation by using NumPy. NumPy dot you see concatenate. NumPy has concatenate operation, where let's do the concatenation of the same array and column. Column means axis 1. So you can see it gives this. Okay, so you can perform the concatenation using NumPy also. But in pandas, it provides a little bit more flexibility. It provides you like little bit customization. For example, you can think about if the objects are indexed differently on other axes, should we combine the distinct elements in these axes or use only the shared value, which is common value? That you can decide. And do the concatenated chunks of the data need to be identifiable in the resulting data, in the resulting object, or the concatenated that axis contain the data that needs to be preserved or that can be ignored. Okay, so those kind of things that we can consider when we that these flexibility is there when we use pandas. Okay, so pandas provides the attributes to customize these things, which is a kind of flexibility that we have. For example, let's use concatenation here. It's more like stacking data on top of one another. Okay, so we have created 3 data frames here. And if we perform the concatenation, then you can see here A, B, C, and 0, 1. C value, again 2, 3. So it just simply stacks data on top of each other, right? So if you want to do that in terms of axis, by default, it will work on only row axis, because it takes that as axis 0, which is row. But if you want to do it in column wise, then you have to specify axis 1. Okay, you can see here, now it creates the data frame, right? So it provides the column-wise stacking, and A only there in B, so the other values which is not there in these other 2 data frames, that will be represented as null here. Okay, so that will create it like a data frame. So what we can do, we can intersect them. So this is simple joining. We can even perform the intersection. For example, here, let's create, let's concatenate S1 and S3 and create a new data frame, S1 and S3. Okay, let's look at S4. Okay, see, we have S4 and let's perform inner joining here. Concatenate S1 and S4. We're going to join S1 and S4, concatenate S1 and S4. So like how we used how attribute in the merge method, here to specify this, you have to use join method to specify the join, which kind of joining that you want to do. In concatenate, you have to use join method, and also you can specify whether you want to do the row wise or column wise. So when you do this, you can see the inner join of S1 and S4. What is that in S1? It has 0 and 1, and S4 has 0, 1 and S 0, 1 and 1. Okay, so when you do this merging and starting off each other, then it will create this data frame. Okay, so you can specify the join method to perform, to specify what kind of joining that you need to do, inner, outer, left or right. You can specify that. Okay, so you can even specify the axis to be used by you can specifically mention on which axis, like A, C, D, E. You want to do only on A, C, D, E, or you want to do on particular rows. You can even specify that. For that, you have to use join axis attribute. Okay, so the same thing. Instead of specifying on axis 1, if you want to perform on only particular rows, then you can specify join A, C, and then let's take B and E. Okay, I have to specify. Okay, here I cannot say inner join because we are specifically mentioning that on which rows we are going to do that. So, look at some other examples where we are. I'm going to create. Sorry, that coordination of 3 data frames. Okay, and I'm going to provide extra keys here so that going to see how it will work with hierarchical indexing. Already these S1, S2, S3 has S1, S2, S3 has keys. Other than that, I'm going to provide one additional key. So I'm just going to see whether it creates an hierarchical indexing. So you can see 1, 2, 3 with AB, FG. So it creates a hierarchical indexing. So when I perform, so how when you perform the concatenation, the series will create a data frame like that. When you perform unstack, that data frame will be converted as a series. See that result dot unstack. If you do this, this hierarchical indexing will be handled as a data frame. You can see 1, 2, 3, and then A, B, C, that will be taken as a separate column. Okay. Do the same thing with axis 1 in column wise. This one is performed in row wise. If you do the same thing in column wise, let me add axis 1. Okay. So see 1, 2, 3, S1, sorry, S2. Let's see, S1, S2, S3. In column wise, we have done it in column wise. Okay. So understanding hierarchical indexing is kind of a little bit of worse. You just got introduced to hierarchical indexing in section 1. So I think if I give you one more example in hierarchical indexing, that will be helpful. So I'm just going to create a data frame with hierarchical indexing. So not hierarchical indexing, simple data frame. Then I'm going to add hierarchical indexing to that. F1 and DF2. Okay. So now when I do the concatenation on keys like level, when I do the use the keys, which is not there here, but I'm just going to add a key attribute, then it will create a new data frame with hierarchical indexing. For example, let me try this concatenation on two data frames, DF1 and DF2. Okay, and what? Access 1. And then the keys will be, I'm just going to create a extra key that will add as a new label. Okay, so here you can see 1, 2, 3, 4, and then this will be the new indexing. Okay, so you can do the same thing in different way. You can use the dictionary and specify DF1 will be for level 1 and DF2 will be for level 2. Like that also you can do that. The same thing can be done using this key pair value. You can say the level 1 key is for DF1 and then level 2 is for DF2. Okay, so you can do the same thing like this, and then you can even use the additional arguments. You can add one more. You can add the label to this row and column separately by using the names attribute. Okay, so the same thing here. Let's add one more attribute, and that is names attribute, and add a list, add it as a list upper for column, since we say axis 1 and the lower. There you can see lower and upper. So that will create the label for the indexes separately. Okay, so the last thing that we are going to discuss in concatenation is if the index in a data frame does not contain any relevant data frame, okay, relevant data in two data frames, then how that will be done? Let's in all these examples we have seen there is a common rows, okay, that we can keep it as a key. But what if we don't have any common indexes? For example, in the data frame that I created now does not have any common data. You can see 0, 1, but it does not has this. It has BDA. 0 is there, but A is not. A value is not matching, right? It does not have any common data. So in this case, when I apply the concatenation, we have to say ignore index. When this happens, then we have to specify ignore index is true. So we have to use the attribute called ignore index. That will ignore that thing like there is no common attribute. There is no, the row index does not match. Here the row index does not match. Even that case, it will just ignore that fact and will simply concatenate the values, track the values in row wise. So next, the last one that we are going to see in section 2 is combine first method. Okay, so sometimes few things that we cannot use any of these methods for in certain situation. Sometimes when the two data set has the index value that is overlapping or full, okay, overlapping as a, like in both data frame, the value overlap or partially overlapping, okay. So in these two situations, you cannot use join or concatenation operation. You have to go for combine first operation. Okay, let me create a data frame to involve this situation. I have created two data frames. Okay, A and B, sorry, series. I have created two series. So normally if you can do that by using the pandas, these are series, right? So you can combine it by using numpy. Numpy has the var operation. By using that, you can combine. You can say var combine var wherever the null value is there. And give. You can see 0, 2.5, and then 0, 3.5, 4. So these values, wherever the null value, the null value will be avoided here. Okay. So here you have to specify wherever is null, that's just avoid it and then combine the other methods. You can do the same thing by using pandas directly, by using the combine method. For example, B combine first, and then what we are combining? A. So what it will do, it will just ignore the null, and then wherever F will be ignored and E will be taken. A will be taken, B will be ignored, C will be taken, D and E will be ignored here, but the D and E value here will be taken. Okay, so wherever null value is there, that will be ignored. So here you can see that F is not overlapping. F value is overlapping here. Here in is null, but here 5.0. Okay, so 5.0 will be taken here. And B value here it is 4.5, but here it is null. So null will be ignored and the B value in this data frame will be taken. So when there is an overlapping of values in terms of keys like this, then you can go for combined first method, which will ignore not a null value, or else we can specify which one has to be taken if there is overlapping of values. For example, let's create another data frame. DF1. Okay, so let's apply the combine first here. Okay, so you can see A 1.0 will be taken. Here we are just doing the DF1 will be the first one, right? So the 5.0 will be ignored here. And B, both are not a null, so not a null will be taken. And C is not here, but C is here, so 2.0 will be taken. Okay. So if you do DF2 and DF1, that will be different. DF2 and then dot have combine DF1. Here the case is different because DF2 will be the primary, so A value will be 5.0. Got it? Since here DF1 A value is 5.1.0, here this will be the primary, but in DF2 will be the primary. So that's all you need to know about combine first. So let me do a small review on what we have discussed, because this section is relatively longer one, because I need to combine everything. I don't want to put it as a separate section, so I just put it together. This section we have discussed about merge method, join method, concatenation method, and combine first method. In all methods, how the same joining operation can be done in different manner by using different attributes of each method. Okay, that's what we have discussed, and the advantages of each method also I have covered here and there. Okay, so that's how you can perform merging of different data frames by using these 4 methods. So the next section, in section 3, I'm going to discuss about reshaping and pivoting of data frames. So that will be the last section for data wrangling. Okay, see you in the next section. Thank you.